Hi, everyone. My name is Jessica, VP Product at Cerebras. I'm excited to share with you today how faster AI speeds are going to help our industry unlock AI applications that are engaging and more powerful. So as a quick intro to us, Cerebras is an AI hardware and software company. We design our own chips for AI training and inference. And we are known for having built the largest chip in the world, the Cerebras wafer scale engine, which is roughly the size of a dinner plate, hard to tell on a slide, and it's 50 times larger than the largest GPU. Our chips allow us to power Cerebras Inference, which is the fastest AI inference solution in the world by over 10x, which means that we can run models like the Llama 4 models 18 times faster than what's possible on GPUs today. So in practice, what this means is that applications running on Cerebras, which you'll see on the left, can finish coding an entire program. If I can get this video to play, there we go. Can finish coding an entire program in the type it takes for models on GPU to repeat your question back to you. So if I stall a little bit waiting for the GPU to finish, if you remember one thing about Cerebras, it should be that, well, maybe not going to wait for the whole thing, but it should be that Cerebras is fast inference. So that's just a quick intro to us, but what we're here to talk about today is the why. Why do we care about faster inference? And the answer to that is fairly simple. AI needs faster inference because, one, we want better user experiences, and two, for higher model intelligence. So let's start with user experience. We're here at the miniCON today because we see that generative AI is transforming the world. It's giving us more powerful search engines, smarter customer support. It's made coding easier than ever before. It's really changing the way we work as we know it. But AI is still also too slow. Now, if you ask ChatGPT what it might take now to be an AI engineer, you can watch it do incredible things like plan out its approach, think through its plan. It'll search the web for resources, consolidate them, refine them. And as you keep watching, you might get really inspired at what it's capable of. And as you keep watching, you might wonder if you really need to know the answer to this question at all, enough to wait 39 seconds for it. And this is because what we're all used to is Google search. Because on Google search, when you type something in, you expect the response to be instant. Typically, you expect the response to be instant, but what we're used to is not the same as what we're getting today, because today, Gen AI is just not instant. And this is from Google, who themselves have published research that we've all followed in the industry for over a decade, that even milliseconds of latency will lead to lower user engagement. But more optimistically, the converse, of course, is also true. So if you think about the history of the internet, every time we've seen a 10x in internet speed, we've seen fundamentally new use cases and applications become possible. In early internet days, we could see HTML text pages with images, and that was already pretty great. And then the internet got faster and we were able to stream music. It got faster and then we were able to have image sharing, video calls. We had movie streaming. And so similarly for AI, this is why AI also needs 10 to 20 times faster inference compute to unlock those better user experiences in new classes of applications. Now, if we go back to our example of using a chat assistant, 10x faster speeds mean you can get your responses back right away, as you can do if you use Flash Answers today in Mistral Lasha, powered by Cerebras, as you can see on the right. Not going to make us wait to watch the rest of that video. And speed also means you can create more quickly. So many of you have probably tried vibe coding, and here we have this cute little app. It's called Cerebras Coder, powered by Cerebras Inference. And I'm going to ask it to build me a calculator app. And you'll hit go, and there it is, literally 1 second. Maybe I want to make it a hexadecimal calculator, and there it is. It's maybe a little bit too simple, so I'll ask it to go back to scientific. And again, there it is. And so when inference is fast, you can manifest your ideas as quickly as you can express them. Now, of course, a calculator app is pretty simple, but Cerebras can also do the same thing with much more complex applications. And so I next want to talk about a different use case where fast inference makes a big difference, and that's in voice AI. So we've probably all interacted with call centers and AI agents that can be pretty frustrating to deal with. You say something, they hardly understand you. It takes a while for them to get back to you. You just want to talk to a real person where you can have a conversation. And so with much faster inference speeds, what you can do is, in fact, build much more interactive, real-time voice agents and assistants. So an example here is OpenCall. OpenCall is a Y Combinator 24 startup that builds scalable customer service solutions with voice. They allow AI agents to answer and handle calls exactly how humans would. And since switching to faster inference, they've been able to reduce overall latency by 90%, while also increasing their customer satisfaction by 20%. So speed, of course, can give you a better user experience, more instant, more interactive. But speed isn't also just for UX. Today, leading AI applications also need higher model intelligence. So, of course, as a baseline, we need our applications to be smart enough to achieve their objectives. And alongside high-quality data, compute has so far always been the path to higher model intelligence. This was simpler, maybe 8 to 10 months ago, when the way that we would build the smarter model was just to make the model bigger, give it a lot more data, and then throw a lot more compute to train the model. And of course, as we did that, the models just kept getting better and better. In fact, we even have scaling laws that predict how compute translates to quality. But of course, recently we started to see that pre-training scaling alone is not enough. And the reason for that is just that we're running out of data. I'm going to quote Ilya Sutskever. He said, "We have but one internet," right? And so we're running out of data, and pre-training scaling alone is not sufficient. Now, to get to the next level of intelligence, we're now moving into this era of inference time compute. And guess what? Inference follows its own scaling law. During inference, the more tokens we use, the higher the intelligence of the model. And this has been published on by OpenAI and multiple others in the last year. If you take a look at this graph, at the recent state-of-the-art Qwen 3 model, which was released just a couple of months ago, in this graph, what we're showing is how well the model does on scientific question and answering on a benchmark called GPQA, where on the x-axis is the thinking budget, which is the amount of compute that the model can use during inference time to think. And on the y-axis is the score on the benchmark. And of course, higher on the benchmark is smarter. And you can see a clear trend here. The more tokens you use to think, the higher the intelligence. And this is also true for coding. It's also true for math. And this is fairly universal. The more tokens you use during inference, the higher the intelligence. And so this is also fairly intuitive, I think, for humans as well. Because I know when I give an off-the-cuff answer to something, off the top of my head, it's usually not nearly as good as if I actually stop to think about it. And so if we break this down visually, it's also fairly clear. So this is what simple one-shot inference looks like. The user, which is a little person up at the top, might ask a question, and they might receive an answer represented by the little black square. But more intelligent models, what we now call reasoning models, they don't just give you an instant answer. Reasoning models will build a plan. They'll break the problem down, they'll solve each part individually, check their own answers, synthesize the end solution, check it again. And all of these steps require token generation, just like our thinking process. When you put that together with agentic workflows, now what you have are multiple specialized agents thinking through a problem and working together, which is what allows today's and tomorrow's AI systems to complete complex tasks. For example, you can tell these more intelligent reasoning agents to set up a Paris trip itinerary, book all of your tickets and save them to your calendar, or draft a PowerPoint presentation based on a paper you might have written, generate the deck, make it more visual. And these are all complex tasks that need more compute and more reasoning. So this is why all the best models, all the state-of-the-art models these days from top AI providers are now all reasoning models. like O3 and O4 from OpenAI, like Claude Extended from Anthropic, and the DeepSeek models. They are all reasoning models. But then if we now have access to these super smart reasoning models, why aren't we using them for everything? Now, why are so many people still using GPT-4o when a smarter model is right there? And the answer again is speed. Quote, because I don't want to wait a year for a response, because reasoning models are too slow, because, quote, they're slow as hell. And I think there's a snail emoji in there somewhere. And so there's this real connection between speed and intelligence. And it comes back to our inference scaling law, where more tokens equals higher intelligence. But practically, of course, we know that given a fixed time budget, faster inference also equals more tokens. So almost like we're giving a math proof here, through the property of transitivity, this means that faster inference equals higher intelligence. If you can generate more tokens more quickly, you can do more reasoning, do more agentic processing in the same amount of time. This means that smarter investment agents like AlphaSense can use fast inference to process 100 times more documents in 50% of the time in an agentic research pipeline. It means that if you're using powerful coding assistants like Windsurf, you can run some of the best coding models in the world. This one here is Qwen 3 Coder, 480 billion parameter model with coding intelligence competitive with Claude Sonnet. It means you can do this instantly. It means you can access it. It means you can iterate more quickly. And it means that now there's really no upper bound to the productivity you can unlock with instant coding. And so what we've done at Cerebras is build a new type of compute so that developers, users like ourselves can unlock better user experiences and higher model intelligence so that we can run the smartest reasoning agents in seconds instead of minutes. And so we're, of course, at Cerebras really excited about what the community is going to be able to do with 10 times faster speeds. And so, if you're interested in trying it as well, you can go ahead and do that at inferencecerebras.ai. And generally speaking, we're super excited to see how the community continues to evolve as they get faster and faster compute speeds.